F A S T. Fast. Frost angle setting technology. Thank you for your interest in frost angle setting technology as defined and protected by the U.S. patent number 5018277. This presentation will show you the intent of the system. The objective is to position an object at a predetermined angle fast and accurately while locking it fast in place. This is done by dividing the increments into two separate indexes where their total will yield the desired results. This example shows how the system works on a machine tool angle vise. However, the system could be incorporated into any product where the setting of angles is required, such as machine tools, surveying equipment, medical equipment, etc. After viewing this, come back to this page and click on these links to see other applications of the frost angle setting technology. There have been many attempts to make a machine tool vise over the years. The ones pictured above are about all the designs that are currently available. The tool room sign vise on the right-hand side is not bad for grinding tools, but it would not be used in production machining. A protractor scale is not accurate enough for most machine parts. None of these vices are rigid enough to drill a large hole or take a rough milling cut. The machining of angled features requires as much accuracy and rigidity as the machining of straight work. This presentation will show how that can be accomplished with frost angle setting technology vise. Here we see the vise on a Bridgeport vertical milling machine. Notice the piece clamped in the vise jaws is tipped at 20 degrees. Fast, the quickest known method of indexing a machine tool vise to a predetermined angle. Fast, the vise holds the part fast in place and more rigid and stable than any other milling vise ever built. This vise sets and clamps any angle from 0 through 49 degrees by simply changing two fitted bolts, or pins. One pin to designate the tens place, the other to designate the ones place. For example, to set the vise at 36 degrees, one would insert the tens place pin in the hole labeled 30 and the ones place pin in the hole labeled 6. Note, the vise pictured above is set at 36 degrees. There is also an elongated radial slot that allows the ones place pin to clamp the vise at fractions of degrees. The base and the body of this angle vise are sandwiched between two side plates. The side plates effectively accomplish two goals. First, they act as a rib to achieve a strong bond between the machine table and the piece part. Second, they index the vise to any full degree increment within 2 minutes time and within 2 minutes accuracy. The stability of this material, 80,000 psi ductile iron, and the stability of the design has made this the best angle vise ever manufactured. Note, there are 15 holes in each side plate. There are 5 holes at the top of the side plate labeled 0, 10, 20, 30, and 40. These holes align with 5 corresponding holes in the vise body. These 5 holes designate the tens place. If a pin is in the 0 hole and you wanted it in the 10 hole, you'd have to pick the vise body up 10 degrees. Another 10 degrees would get you to the 20 hole and so forth. Likewise, the 10 hole at the bottom of the side plate labeled 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 designate the ones place. These holes align with the 10 corresponding holes in the vise base. We removed the side plate so you can see those corresponding holes in the base and body. If the pin is in the 0 hole and you wanted it in the 1 hole, you would have to pick the vise body up 1 degree. Another degree would get you to the 2 hole and so forth. Notice that Each of the tens place holes use all 10 of the ones place holes while the vise is indexing through its 50 positions. The next 50 slides will show you each one of the 50 positions this vise will index to, 0 through 49 degrees. As we can see, when we move the ones place pin from the 0 hole to the 1 hole, the vise goes up to 1 degree. Likewise, from the 1 to the 2 hole, the vise goes up to 2 degrees until it gets to the 9 hole, or 9 degrees. After the 9 hole, the ones place pin goes back to the 0, but the tens place pin goes to 10. The vise is then at 10 degrees. Then when the ones place pin keeps advancing 1 degree at a time until it gets back to the 9 hole, or 19 degrees. Then the 1 place pin goes back to 0 and the 10 place pin goes to the 20 hole. The vise is then at 20 degrees. We continue to tilt the vise up until we get to 49 degree position. To obtain a fraction of a degree, insert the tens place pin as normal. Insert the ones place pin in the 10 degree elongated slot on the back. Snug the nut finger tight and set the angle by indicating across the sign bar. And lock in place by tightening the ones place pin in the elongated slot on the back. This vise is set at 22.5 degrees. The two side plates on this vise effectively create triangular trusses that hold the vise body to the base. This is a superb improvement in rigidity, stability, quickness, and accuracy of a vise design. It will change how machinists will consider machining a part. The angle vices in the past were not rigid and were only used as a last resort. The rigidity of this vise will allow a number of machine features to be machined with the vise at its 0 degree setting. The vise will stay on the milling machine while machining parts with angled cuts and parts with straight cuts. This saves the time it takes to load and remove the vise from the machine. There are a lot of angles that will be face milled or slab milled with standard cutters. This eliminates the need for angled or cone-shaped end mills and yields better surface finish because of the constant surface footage can be achieved. The vise indexes more than 45 degrees, therefore features can be machined at any angle between 0 and 360 degrees on a rectangular part. In this cross section, we see how the adjustment screw adjusts and maintains the proper running fit. In this cross section, we see how the half spear pushes the jaw down as it tightens the part in the jaws. In this cross section, we see the flamed hardened legs. They help reduce wear and keep the vise more accurate. In this cross section, we see the needle bearings and thrust collar, minimizing friction and increasing the clamping pressure of the vise. In recent decades, the geometrical design of the vise jaw that forces pressure down on the vise legs and also pivots several thousandths to conform to the shape of the workpiece has made a dramatic improvement on the holding ability of the vise. The machine tool industry has recognized this as the uncompromising dampening system, allowing heavier milling cuts while yielding better finishes and holding closer tolerances. We've incorporated this geometry into the frostbite jaws. Frost angle setting technology, in conjunction with frostbite jaws, makes this vise unquestionably the most effective way to hold a part at a predetermined angle. The two mounting holes are offset from the horizontal centerline of the hardened jaw plates. This allows the plate to project above the fixed and movable jaw. Jaw plates can be mounted on either end of both jaws. increasing the clamping capacity. The jaw plates can be mounted in any of the 4 positions shown above. This slide shows the vise specification. It also shows the features that set this vise apart from previous vise designs. Rigidity. The rigidity of this vise allows milling machines to hold closer tolerance while yielding better surface finishes. Stability. This vise will stay at a predetermined angle while taking heavy milling cuts and also down pressure as when drilling. Quickness. This system allows the vise to index to any angle within 2 minutes, saving valuable machine time. Direct reading. Any machinist can run a machine with much more confidence if he can glance at the direct reading system and be sure his vise is set at the correct angle. Experience required. An inexperienced operator can set this vise with less than 1 minute of instruction. Accuracy. The plus or minus 2 minutes that this vise will easily maintain is better than is required in almost all milling applications. Parts for the frostbite jaw locking mechanism are identical and interchangeable with those on a Kurt vise. The keys and the pivot bore in the base are compatible with Kurt's. This vise will mount on a standard Kurt swivel base. This vise is extremely rigid at 0 degrees. It will add that 4th axis to a vertical CNC machining center. You will soon realize that it's efficient to manufacture many parts at 0 degrees, and then at a programmed stop, index the vise to another angle to do an operation that you would have previously done on a secondary operation. This will yield more accurate angles and improve the part flow throughout your shop. Thank you for sharing in the dreams of frost angle setting technology. We believe this will become the way to set angles. For more information, call or write Buddy Frost, P.O. Box 213, Clinton, Maine, or email budfrost@gmail.com. Feel free at any time to call me at 207-426-2651 in the wintertime, 207-897-2681 at our camp in the summer.